Hello, friends. Good morning, good afternoon, good evening, wherever in the world you're joining us. Welcome to Open Source Friday. So, like many Fridays, if you friends know me, I need a little bit of a thumbs up to make sure that you can hear me and you can see me because we change things about a little bit. So, if I could just get on the chat, that'd be great. Or even our guest, even if Charles can like nod because I can see you. Excellent. Amazing. Thank you. Thank you, Charles. Welcome, everyone. Welcome to Open Source Friday, the show sponsored by GitHub, where we celebrate the maintainers, the contributors, the makers, the amazing folks like yourselves who are supporting this incredible ecosystem. So sometimes we talked about projects that are, in essence, rooted in problems that hold like a significance to everyone, right? Like you feel this pain and this is why you come to the show. And I think today is one of those days. And if it's not, then hopefully we're gonna get to share some real thought leadership here with an industry expert. So beyond the project that we're gonna be talking about, we're gonna actually touch on something that I think is relevant to everyone. And it's gonna be a really great conversation. Plus, he is going to also generously give us a demo. So, welcome to Open Source Friday, everyone. Thank you for being here. Where are you joining from? I want to know where you are. I'm joining you from super rainy Florida. I don't know what's happened today, but it is very dark and Seattle outside. If you caught the pre-roll and had a look at that Copilot coding agent and haven't tried it, please give it a try. It's actually a lot of fun, almost as fun as that music from the video. A little bit obsessed with it. I hope you had a really awesome week. It was a long one for us, but here we are. We made it to Friday. So I am super thrilled because today we're going to have Charles Lowell join us. Charles' handle is the same everywhere, and it's a really good one. I'm going to go ahead and share that now so you can give him a follow on Blue Sky, X, LinkedIn, all the places. But like I was mentioning, Charles is founder of a company called Frontside, and him and his team have been pushing boundaries how we think about JavaScript development. He is the creator of Effection, which is the project we're going to be talking about today. And this is a library that brings structured concurrency to JavaScript. And full disclosure, how many of you have actually thought about structured concurrency before? I know that's definitely not been in my in my world. But if you never heard this term or you don't understand why that would even be relevant to you, don't worry, don't be discouraged. That's what we're here. Charles is taking a pretty esoteric computer science concept. I mean, there is some of the references that we're going to touch, and I'm going to share some of these papers that actually he generously just shared this blog post that I only started to read the first 2 paragraphs and my brain exploded. Um, by understanding how this works and his industry expert, he's been able to create this into practical tools, right? And solving problems with Effection that JavaScript developers face every day. So let our eyes not glaze over and bring Charles onto the stage so we can get started. Welcome, Charles. Thank you for being in Open Source Friday.
Oh, thank you. Thank you so much. It's great to be here. I'm excited to talk about Effection and open source and structured concurrency and all the things.
Amazing. I don't think I gave you too generous of an intro. I got a little bit distracted because this blog post that you shared with me, I was like, wait, what? And the blog post in actually, let's go ahead and share that so that folks can just take a gander, save the link. This is just gonna take you to this. It's been a few years, right, since this article was actually released. And it's got a bit of citation from like some really important papers from like the 60s. But that was just a little bit like my nerd heart exploded, and I'm definitely going to be digging into this. Before we joined the live, you were telling me you need to sit down with this and like take like an hour to read it, to really digest it, and really understand it.
And it, like I was saying, it really does a good job of treading the fine line between being a boring academic paper and being like, oh, this has really concrete examples that I can relate to my own experience. And I think that's one of the reasons it's so important, is it has all of the impact of an academic paper. Like when I read it, I was, my mind was blown. But at the same time, I didn't have to read it 20 times and parse every little subparagraph. It's well written and it's practical.
Amazing. Well, folks, I'm going to pass that link on the chat and all the places. If you're watching on LinkedIn, would you be an absolute corazon and post this link that I'm sharing, please, because our LinkedIn and StreamYard connection is broken. So if you don't mind just grabbing that and posting it for me, that'll be amazing. Otherwise, I will do it at the end of the stream. But Charles, where are you based? I think I briefly touched on the company that you founded, but if you don't mind just giving us a bit of background, that would be amazing.
Yeah, so I am based in Austin, Texas. It's where I was born and raised. And as far as the company goes, the name is Frontside. And it's called Frontside because we initially got our start writing user interfaces. I was doing a lot of work on like back-end work back in the early 2000s. And I started writing user interfaces in Java, Swing. And one of the things I realized, especially once we started moving towards the web, is that there were just a lot of patterns on the back end that were applicable to the front end. And so we wanted to specialize in writing software at the boundary where humans and computers connect. And so hence the name the front side. Now we've since swung the pendulum back and forth between the back end and the front end many times. We've done a bunch of different stuff, but that's the original conception of the company.
Amazing. Okay. And so
I should say we do consulting work, and we help people solve really difficult problems, usually with JavaScript, TypeScript.
Great. Well, let's swing into Effection, because I want to know exactly what was the moment what was it that prompted you to create this project? Like, was there a specific thing that made you think, we desperately need to do this differently?
Yes. So we can rewind till about 2016. This is actually before that paper came out, but the idea of structured concurrency was already floating around between a couple of people who were attacking really difficult problems and looking for novel solutions for them. And a colleague of mine in the Ember community, because we were doing a lot of Ember at that time, a guy named Alex Matchner, wrote a library called Ember Concurrency. And I don't know how he had found out about structured concurrency, because it was a blog post written by the 0MQ author at the time. But what it allowed you to do in terms of managing your asynchrony and making sure that things were canceled at the right time and that you didn't leave objects around or resources around too long, it made it very simple to wrangle asynchrony in a way that wasn't really possible other ways. And so I used that library quite a lot. But then we moved on from Ember and we started doing React, and we ended up doing a little backswing onto the back end. I had been, we had been doing a lot of front end work, and we were doing back end work. And every time I would come up against a problem that involved managing a bunch of state and a bunch of asynchrony, and I would have problems with it, I was like, gosh, I wish I had that front end library that I was using in Ember. And so that's how Effection was born. We were writing a testing tool that was managing processes and browsers and a bunch of other, it was wrangling a bunch of state, and we needed some really high power primitives. And so that's when we started porting this idea of Ember concurrency into a library that was not just front end, not just back end, but was a general structured concurrency library. And that was Effection. And one of the reasons we call it Effection is it's a play on effect. So it's a way of managing your effects. So we call it structured concurrency and effects. But at the same time, Effection, means love and tenderness and kindness, and we really try to embrace JavaScript. So that it's affection towards JavaScript, in the sense that we're not trying to change JavaScript into something it's not. We're not trying to bring a different runtime into JavaScript or be something that's not JavaScript. We really try to hew as closely to the JavaScript APIs to provide structured concurrency for JavaScript, but nothing more. So effects and affection for JavaScript is where it comes from.
Okay, I love that. I love that reference to the name also being kind. I'm all for kindness. And listen, folks, I mean, JavaScript developers are opinions. Opinions are plenty, right? But I think you were definitely trying to solve your own pain point. You have a way that you were doing things that seemed to work, but it sounded like mostly was hidden time bombs. So then Effection is born. And how did you create this to fundamentally differ from the traditional way that promise-based async code was handled before?
So I'm not quite sure I understand the question. So it's how do we go about
I guess the key difference between before and with Effection.
Okay, so if I can say it in two ways. First, we try to make it so that it feels extremely familiar. So if you know how to use promises, if you know how to use async functions, you will know how to use Effection. If you know how to use async iterables, you'll know how to use Effection. We have analogs for each one of those things. In fact, we call it the async Rosetta Stone, because there is a direct translation for every async construct in JavaScript. We have a construct in Effection that is almost exactly the same and will feel familiar. So that's one. But the underlying question is why? If it's exactly the same, what's different about it, right? That's your question.
Right.
And the difference is, let me see how I'm going to try it, is we always respect finally blocks. I would say that's your asynchronous code always works like the synchronous code. When you do a try finally, your finally block is always going to run. And that's not something that's true with async await. And if the more technical explanation, or the more kind of formal definition, is that the lifetime of an async function is determined by the lifetime of its innermost promise. So if I have a chain of async functions, it's awaiting a bunch of promises, I'm calling another async function, which calls an async function, which calls an async function that has a promise, and that promise neither rejects and it doesn't resolve, or it doesn't do either of those things, then that entire chain of async functions will not resolve or reject without some sort of intervention, whether it's passing a cancellation token or an abort signal or some sort of programmer managed coordination between all of those things. Effection is different. The lifetime of your function, we call them coroutines, but it's basically an async function, is determined by the lifetime of the outermost. So if a function ends, either through returning or rejecting or being canceled, then any function that was created inside that chain is immediately halted. And obviously we need to wait and return, make sure those values return. But that's the fundamental difference, is the inversion of control. The outermost is controlled by the innermost with async await. With Effection, the innermost is controlled by the outermost.
Okay, I think
Does that make sense?
That was brilliantly explained. No, that was brilliantly explained. Because I wanted to ask the very simplistic, how is this better? And it sounds like the same. And you didn't actually. So it's not just theoretically elegant; it's actually impactful. Okay.
Right. And what that means then in practice, the next step is everything that you call represents some sort of resource or some sort of state. And so because when the outer function exits, everything is cleaned up. Okay. And you don't have to worry about how it's going to be cleaned up. You can just have faith that it will. Another way I like to think about it, another analogy that I think is really important, is Effection provides a different set of air to breathe in. So, I'm old enough to remember when garbage collection was controversial. So nowadays we don't think about garbage collection. Every language pretty much, unless you're doing assembly or you're doing like low-level C, is garbage collected. And I use garbage collected in a very wide term. Like I would consider under this formulation, Rust is also garbage collected, in the sense that not any particular mechanism of garbage collection, but that I don't have to worry about memory. The runtime worries about collecting the memory. So if I declare a variable and I assign it to a number, I've got to allocate some memory to put that number in. But I don't have to worry about when I'm no longer using that number to go and tell the computer, hey, you can go ahead and release this memory, put it back into the pool for allocation because I'm not using it. That's something we just don't think about, but it's incredibly freeing. And so structured concurrency is the same thing, except for effects and concurrent processes, is that we can use processes, we can use effects, we can use this state, but we don't have to think about them being reclaimed or managing, saying, okay, now you need to go free yourself.
Okay, that sounds super, super interesting. I love how you said, yeah, I'm old enough to remember to remember the nightmare that it was to clean up. Yeah, people don't think about that. Like those processes fails, and then how are you supposed to go back if it was 3 out of 5 or whatever? Like that's a nightmare.
It's a nightmare.
And then for resource leaks, what you just talked about, like that, having that be a part of an integral part of Effection. Okay. If I'm a JavaScript developer right now and I'm thinking, okay, I want to use this, like, tell me, what can I do? How can I get started? Should we look at a demo now, or should we talk theoretically about a little bit more? I mean, I'm sold. So I'm like, might show my
right.
What do you think?
We can go to the demo. That might give a little bit of just a better picture of what it is that I'm talking about.
Let's do it.
So yeah.
Let's do it. Yeah, like that. That'll give us a little bit more color. And folks, if you are watching this and you actually been thinking about this, or you actually use Effection, please let us know. Please post it on the comments there. I'm scrolling the repo on the screen right now so that you can go by and leave a star on it, please. And then I'm also going to share, there is a community. We'll talk about docs and all those things at the end. So the folks that want to get involved, they can go ahead and get started. But I'm going to drop the link to your blog post as well. All right. And let me know when you're ready. I'll go ahead and share your screen.
Yeah, I'm ready.
Let's see. Where are you, screen share?
Okay.
Let's see. Chris, my reaction, exactly. Gasp. I love it. We have the best folks here. I'm not seeing your window pop up yet, Charles, but now I do. Lovely.
Okay.
Here we are. If you don't mind zooming in just a tad, I think, so that we can. If you can zoom in just a little bit. But it's for those of us who refuse to wear our glasses because the reflection is too bad on the screen. Brilliant. I can see it all now. Thank you.
Is that better? Okay. Let me do this one. Let's see. What is it? Okay. Fantastic. Okay, so everybody can see my screen. And so here I have the simplest Effection program. I've got a main function. This is how you leap from the async await world into this world of structured concurrency. And this function, all it's going to do, my main program, all it's going to do is it's going to suspend. And so it's basically doing very, very little. You can see here's the type. And I can, let's see, I can put the type over here. So it's just going to pause the current operation. And you can see also the type, again, the types are going to pop up here. It's an operation. That's the Effection equivalent of a promise. So this is a operation that yields nothing. And instead of awaiting a promise, I'm going to yield to an operation. Okay, and this operation suspends forever, or so we think. So let's see what happens when we run this. I'm going to say npm run start. And here is my main thing running. It's not doing anything. But one key difference is that I can control C out of it. And that is, and we'll dig into there, but that's one of the key differences right there, is I have actually broken out of the suspend and I've told the main function you need to return immediately. And so what it does is it actually kills off the suspend and the function returns. And we can see this in practice if I put a try finally around this. I'm exiting. So now if I run, I'm still going to suspend, but then when I control C, you can see it actually printed exiting. So it actually ran the finally block.
Okay.
Even though this ostensibly waits forever. Really what a suspend is going to do is it's going to wait until the operation is shut down. So are any questions about that so far? Because that's already a little bit different.
Yeah, let's see in the chat if anyone has questions. So wait, if you're not just ignoring it, right? Like you're actually, it's like a true cancellation. Like
it's a true cancellation. I'm actually returning from line 5 immediately.
Okay.
So what I'm basically telling this coroutine to do is return immediately. And so whatever it happens to be doing, whether it's suspended, whether it's sleeping, whether it's reading bytes off the network, it's going to return immediately. But at the same time, it doesn't just leave everything be, it returns immediately and it runs any shutdown. So returning still means returning. You still have to execute your finally blocks. But okay. I didn't have to, at no point did I have to say anything about cancellation. It's just implicit because this suspend operation is part of this main function, which is a part of the main Effection process. So when it ends, remember what we're saying is main is that when you hit Control C, main is ending, therefore this must end, therefore this must end.
Oh, that's very interesting. And I don't want to, and stop me if this doesn't make sense for where we are now, but like let's say, for example, for a website that is waiting for a task from like the user, like there is an input, whatever it is, like it's going to send a query to your API or something like, and you navigate away.
Yes.
So how does that work in Effection then? Because then those are not really suspended operations because the cancellation signal has already been sort of handled. So how does that work then?
So what in a browser, what ends up happening is it will do the same thing. We actually listen to, gosh, I can't remember what exactly the event that we listen to in a browser. I think it's on Navigate Away or something. I can't remember. Let's see if we can actually go to the source here. So in the browser, yeah, on event unload.
Okay.
We'll do the same process, the same interruption. So on different platforms, what it means to interrupt and cancel is different. At the main level, we'll also go to see how you can actually halt things. You as in Effection, you can start tasks and you can halt them yourself. So that's how you would do it on a browser. Is basically on some event you would be running everything, because there's in structured concurrency, it really does mean there's a tree structure, and so every single piece of work that is currently running eventually rolls up to some root task. And so you just tell the root task to stop, and then everything will stop.
Okay, thank you.
So in this example, one of the things I wanted to show is like managing something that's very stateful. So like, let's actually start, we're running in Node here, and so we can actually start a server. And so let's see, we'll say let address equals use server, and I'm going to give it a message that says hello world. And I have just a simple echo server where you just give it a message and it will serve that thing over HTTP.
Okay.
Let's see if here, let's log the address, and then we can now run our server, and you can see here's our actual server running on port 49840. Now, what's nice about this is I told the server to start, but then when I cancel and I exit, the server itself is going to get shut down. So it's going to release that port. And I don't know if have you guys ever had that like e-adder in use error where you forgot to like stop a server, and something happened, someone killed the process and you forgot to do it, and then you start it again, and it's like, nope, something's already listening to that port, because you never told the operating system that you were done with it.
Uh-huh.
I don't know if anybody's ever had that problem.
Let me scroll through the chat and see if there is any questions real quick.
Meantime,
let's see. Yeah, Chris has suffered from this. You suffered that pain before. Right.
Yeah, and so this completely and totally alleviates that pain, because you don't have to think about it, because it is actually releasing the port. So I'm just going to make this a little bit easier so that I can click on the links here. Let's see, we'll give that a try. Okay, so now I can go here. Tell you what, why don't I'll just do it with curl. And you can see it's saying hello world. We want to say hello world, don't we? Okay. And then, oops. Oh, I've got a different port. Tell you what, I have a parameter. Let's just use port 8000. There we go. And that now we're running on 8000. And we'll change this. We'll make this port nice and stable so that we can do it like that. And it works. We can start, I can create multiple servers here. So let's make this port 1 and port 2. Let's see why doesn't it like this? Oh, of course not. Okay. Fix that up now. Okay. One more time. Okay. Now I'm just running 2 servers.
Okay.
We'll make this one. Let's make this one say hello planet here. And again, I'm running 2 servers. I can curl that one. I can curl this one, and you can see I've got 2 different servers, but I don't have to worry about shutting them down. So you can see that's actually a pretty sizable chunk of work to embed an HTTP server in your process, but Effection makes it just completely and totally painless. And I don't have to worry about shutting these things down. We can look over briefly on the code. This uses what's called an Effection resource. And without going too far into it, it starts a server. You can actually, the resource won't return until the server is listening. But then here's the key. We have a try finally around providing the resource. So here I'm providing the resource, but then I have a finally block that always runs, and then inside it, I'm going to close that server. And my process will not exit. My resource will not be considered to shut down until this async thing finishes. And that's a very subtle point. So I actually, when I hit Control C, my process doesn't actually exit until I get positive confirmation that this port has been released and that this port has been released. So that's it in a nutshell, is being able to really wrangle highly stateful things and know that when they pass out of scope, they're just going to get reclaimed.
Oh, this is fascinating. Okay.
So we can stop there for questions. I have one more demo that I think drives home the point even more.
Awesome. I think there was a question actually from Chris, and Chris, thank you for being here. And you did touch a bit on being that JavaScript is single-threaded. So yeah, this is all single-threaded still.
Yes, this is single-threaded still. Just in the same way that async await is single-threaded. If you want to use multiple threads, you can use workers. And we actually have it's not part of the Effection core library, but we have what's called Effection X, which is a series of user-contributed Effection libraries that we have for managing things like workers and WebSockets and all the things. There's an ever-growing list of things that you can manage as a resource. So if you wanted to do something multi-threaded and multi-core, you could use a worker. But you use the worker in a very similar way to the way you use it. You use a server. It's a resource that the worker will get reclaimed the moment it passes out of scope and you're no longer using it.
Okay, that's awesome. We'll be sure to touch on that at the end, because I do want to have folks have an opportunity to see how maybe they want to contribute to that. You just mentioned that there's a good community contribution there. Awesome. This is super interesting. Show us the next one, Charles.
Okay, so I was casting about for ways that you could demonstrate what Effection is capable of, but still have it connect to a problem with which we're all familiar with. Okay. So we've all used like an off-the-shelf monitoring library that will like restart. So every time I've been making a change to these servers, I've been going and I've been hitting Control C, and I've been restarting it manually. But what we'd like to do is, like, as we're developing, we'd like it to restart for us. And that involves like using something like NodeMon or some of the other things, but usually you have to reach for something else because it's actually a pretty gnarly problem. You have to handle a lot of cases. But with Effection, actually writing a file watcher and process manager is pretty simple. So I was thinking we could do that here inside the demo.
Awesome.
So I have here a little watch script set up. And what we want to do is, while some condition is true, we want to be able to, we want to say that we want to do some sort of restart. So I'm going to use two helpers that I have, the use command and use watcher. They're very similar to the use server that you saw in the other demo. The use watcher is just going to use a file watcher, and then when the file watcher is no longer needed, it goes away. So what we're going to do is we are going to say, I'm going to also use the scoped helper, and we'll explain what that is in a little bit. So that you can, but just kind of follow along right now without kind of knowing what that's going to do. And we're going to, what we want to do is we have this command and we have the arguments, and we want to basically, let's start with a watcher, and we want to say let's see, we'll say changes is going to be use watcher, and we want to look at the source directory here. Okay, now if we look at the type here, this is going to be subscription, a file change info. And in Effection, a subscription is similar to an async iterator, and a stream is similar to a async iterable. So you can see this thing right here. This is a stream. You evaluate a stream to get a subscription, same way that you convert an async iterator into an async iterable. And then what we can do, let's just say console.log changes detected here. And if we've done our job right, then, oh wait, we want to wait for the next change. Okay, now if we've done our job right, let's do, this will be npx tsx watch, and then we want to say npm run or npm start. Okay. So it's not going to do anything right now, but if I go over to my main function and like I say, I want to change this to hello universe, you can see it's detecting changes.
Oh.
Okay. Now what I can do is over here, and that's just it's going to loop over. It's going to create that watcher, wait for the next change, and then say changes detected. Now what I can do here is I can say I want to use a command, and we're going to pass the command and the args to this use command. Let's see. Did I misspell it? Yeah, I did. Okay. And what that's going to do is that's going to start running this command. Okay. But what we can see here is that it's starting our server. But now if I go over to my main and I want to change this back to hello planet. Oops, what did we get here? Did we get an exception? Uh-oh, we got an EADR in juice. Here I am talking about how we shouldn't be getting that. Let's see. Interesting. Okay. Well, let's see. I might be getting too many events. I might have to debounce.
Okay.
These, but let's see. Let's see what happens if I add a sleep here. Okay. Okay, nope. It's back to the drawing board here. I do have some bug in here.
Okay.
Where I'm not actually tearing down this command. Probably here's what needs to happen. Okay, I've written my command helper. I kill the process in my command helper. So you see here's the command resource. And the problem that I'm running into is I actually send the signal to the child process to kill it,
okay.
but I don't actually wait for it to finish.
Okay.
So really what I probably need to do, I don't know if there's some killed, is there a killed promise? Property indicates, is there a promise I can listen to find out if the child is dead? Okay. So what I can do probably here is I can do. Does everyone understand the problem? The bug in my code? It's a little bit subtle, but the processes will release the ports, but because my manager is not waiting for them, it's not waiting for the process to end. It's just sending the signal and saying I'm done. So really what we ought to be listening for the standard out to close. And maybe there's a on close or exit. Yeah, so let's try this. We can say exited with resolvers. I guess we could make it with a code like that. And then on exit, we can say code. Well, let's just make it void for now. We don't really care. We can say exited.resolve. This is very similar to promise.with resolvers. And then we can say proc.kill, and then we can say exited dot yield exited operation. And we should probably doesn't matter too much, but we can, well, let's see if that works for us. It's either going to hang or it'll work would be my guess. We'll see. Okay, so let's make a change. Okay, it's hanging because we're never receiving that exit event. Let's try close.
I'm loving this. This is what live demos are all about, okay? Like this is how the real goes.
Okay, what event is the process what event is it gonna throw when it actually exits? That is the question. On disconnect, on error, on exit.
It's not an exit. It's not a failure. It's not a. Hey, folks, if you're watching.
What is the event that I need to be listening to? Well, we can fake it too.
Let's fake it. I mean, but basically, you were showing us how to select, like, create that custom monitoring, basically.
Yes.
Inside the task, which is pretty awesome. And I guess you can make it as granular as you want, right? And listen to whatever event once we figure out which event it is.
Which event is actually going to cause it to close. Okay, well, I think we're going to have to declare bankruptcy. And there is some way to listen to the fact that this process is closed. It might be just waiting until we could look at the process standard out. But until that thing is actually closed, we can't proceed. So in theory, you get the change, you use the command. Here's the point to try and demonstrate. Once we get the change, this function right here is scoped, which means this command passes out of scope, and so it will be shut down. And then once it's shut down, we can then continue our next while loop. And so that's how the life cycle of the command is not managed by a cancellation token or explicit token. It's managed by whether it's in scope or not, whether it's between these curlies. Just the same way that the lifetime of a variable is managed by the lifetime of a variable is managed by which curlies it lies between. And so once the loop passes outside of these curlies, the command needs to be killed. And so this watch loop is once you kind of understand how structured concurrency works, it's very clean and it's very obvious how it's working. And let me see if I actually have this in the Git history. Let me see if I can look at what the watcher looks like here.
Welcome, Jared. Jared says, wait for the port to be closed. But what is that called? What is the
if we can, what the problem is I'm waiting for the server to be closed. Tell you what, let's
And thank you, Jared. Let's see.
Yes. We have this here. Okay, let's see if we can actually get in there debug, so we can say I'm going to use the error console because it's synchronous.
Okay.
Okay. So sending the SIG into the process, and then we want to go into our use server, and we want to see all right. Let's see what happens here. Okay. Changes detected, sending SIG into process.
Okay.
Unhandled error event. Okay. So that's interesting. What is the error event? So maybe there's an unclosed error event. Anyhow, I'll have to revisit this.
Okay. Yeah, no, that's all right. But the general idea is there, right? Like
the general idea is there. Usually, boy, I haven't gotten bitten by the demo gods in a really long time, but that's probably hubris.
You were due. You were past due.
I was due. I was way past due.
You were past due. Listen, my friend, 2 out of 3 is a heck of a record, okay? Like 2 out of 3, I think is pretty solid. All right, this is great. For folks who are watching, if you have any questions about Effection itself, please let us know. Like, take advantage of having Charles here for sure. Thank you to everyone who's joining. Jared, thank you so much for joining and actually participating in the live debugging. This is awesome. You know what's going to happen? We're going to end our stream, and then in about an hour, you're going to have that eureka moment, and then you're going to tweet about it and tag us all in it so that we can take a look and figure out what was it that was going on. But I wanted to ask you, so for folks who are, all right, let's say before Effection, obviously there wasn't a ton of options for developers. Now for developers who are watching this and are thinking, okay, I'm thinking about adopting this. Is it the learning curve? Like, how can folks get started? I do think it's important to actually read that paper because that's the tone and the importance of why, right? Like this is having skimmed like the first 2 paragraphs, my friend. So it's not like I've read it myself. But for teams who are, this is how they regularly live. They live in this promise-based world. What does it look like to migrate to start using Effection? What does it look like to start adopting this, and how can we get folks to get started using and contributing too? Let's talk about your contributors and how folks can start participating.
Yeah. So I would just echo your recommendation to go read about why structured concurrency is a solution and why there are problems that can't be solved with the tools. Why just normal async await code is not a solution. Why explicit resource management is not actually a solution to these problems. So in order to understand and to kind of think about what are the set of problems they solve and how the problems often don't manifest themselves until you are running at scale. So when you're doing little toy problems like these, you can use a fundamentally less powerful primitive. But once you're managing thousands of servers or having tons of different events, then you actually need a more powerful primitive. I think there's also a lot of great resources. Before we start to talk about the Effection itself, there's a lot of great resources in the Swift community, in the Java and the Kotlin community, where they're actually managing user, these are programming languages that are developed specifically for making UIs. And so you've got all kinds of events happening. You've got events that are coming in from the server, from the user, from all over the place, from all the different services that you're connected to. And so why is it that they have opted to go with structured concurrency as opposed to some other solution? As far as getting started with Effection itself, I mentioned earlier, and I should have provided that link to you before, the Async Rosetta Stone is a very, very helpful resource. So it just shows you the kind of one-to-one differences between, if I'm familiar with how to do this in Async Await, I can do it in structured concurrency. That's a really great resource. We try to be very, very thoughtful about keeping as close to JavaScript as possible. So the only thing you have to learn is structured concurrency. You don't have to learn anything else. Drop into the Discord. We actually have a lot of people in there. It's who are working. We've got Effection started mostly on the back end, but we've got some people doing some interesting stuff, integrating it with React. There's some mind-blowing stuff where where people are modeling an entire React component lifecycle with a single function, and instead of returning fragments of JSX to render, you're actually yielding JSX, and it kind of turns the model onto its head. And it's actually, once you see it in practice, the first time I saw it, I was like, whoa, that's really intuitive. And you can do it because you have more of a component model of computation. Like Effection is very similar to React, except instead of components, you're talking about functions. And I should have probably, that's another great way to think about it, is without rambling on too much, but I think this is an important analogy when you're kind of first grappling with it, is the expectation that you have with something like React, which is something very familiar to us, which differentiates it from something that came before, like jQuery, is that when I render a React component, if at any point the parent component ceases to be rendered, then the child component is not rendered. That's something that is very intuitive to us when we've worked with React for a long time, right? We have a component tree, and the lifetime of the child components is bounded by the lifetime of the parent, right? It's the same thing with Effection, really, except instead of a UI component, we're talking about a general piece of computation, a general function. So every function has a parent, and when the parent stops, the function stops executing. So there's a lot of stuff going on, people talking about that in the Discord. And then I mentioned the documentation. We also have a library called Effection-X, or not a library, it's a repository that we should also post the link to. It's the same thing, same path as Effection, just with an X at the end, which just stands for extensions. So I mentioned before that we keep Effection very, very tight and lean. It's only about 4K compressed. So it's really tiny. It's really faithful to JavaScript. It has things that, like with resolvers, which should be familiar to JavaScript developers. But that's not everything there is to programming. So we have things for managing WebSockets, for managing workers, for doing streaming helpers to map and reduce and do back pressure, and lots of different stuff in there. What other really important resources are? There's good documentation for both Effection and those libraries as well. And yeah, come in and say hi in the Discord. It's really mind-bending stuff, but it makes your day-to-day a lot easier. And You can just get started. There's an embedding API. So if you don't have a main script, like everything that I've been showing to you, like Effection is the main entry point.
Okay.
There's also an embedding API, so you can just start sprinkling it inside your application. So you don't have to, Effection does not have to rule the world. It's designed to be very easily embeddable. And so you can read about the embedding API. And another thing, a good way to get started. I think that's all I can think of at the moment.
Okay, no, that's plenty. I've shared the link to the library repo where you have the community contributions. Folks, just join the Discord. I mean, start asking questions, right? It sounds like you have a really diverse community in there, and that's cool. You go talk to your React folks. That was one of the final things that I wanted to ask you about how we play with different frameworks and do we play well, and you just sort of touch on that. Amazing stuff. Charles, is there anything else, any other advice that you can leave us with? I think we covered quite a bit today, and if nothing else, I feel like the bug is planted. That the bug is planted, and folks can go take a look at the paper, go take a look at Discord, and start. I think what you just left us with, kind of sprinkling it, and not it doesn't have to be the king of all things, but just sort of start experimenting and see how this can improve whatever it is that you're working on. But is there anything else that you can leave us with?
Yeah, I would end with this, and it has a lot to do with the design of Effection and why we wrote it. But it's a general stance towards programming, and I would say that if development doesn't feel like flying, it should feel like flying. It should feel effortless, and if it doesn't, and goodness knows, we've all been there where it feels frustrating and like you're fighting and you're wrestling with your tools. If it doesn't feel like flying, there is a better way, and you should be searching for it. And Effection is our idea of what it feels to fly.
You need to put that on a t-shirt. I love that. That's epic. That is awesome. I love that. This is such an example. Like, that's so interesting to me, because I think sometimes you just get used to suffering, and you so in your way because you don't take the time to actually see if there is, and 9 times out of 10 there is a better way, right? It just takes a bit of learning and a tad bit of a curve of adoption, but then you're on the other side and then you fly. So let's get out of our own way and go explore. This is awesome. Awesome. I know there's a lot of folks that definitely have not been thinking about structured concurrence at all, myself included. I'm going to read this paper. This is going to make for some interesting Saturday reading. And yeah, Charles, this is amazing. Please come back. Right. I think there's a lot we can learn from you.
All right. Well, I look forward to it.
Awesome. I'm going to share one more time your social here on the screen, and it's the same handle in Blue Sky and everywhere else. So you can go and give Charles a follow. And so grateful to have you at Open Source Friday. Thank you so much.
Thank you so much for having me. This was really fun.
All right. Well, folks, there you have it. When we think you know it all and we know nothing. That was super, super interesting. And about as real as it gets. Listen, you're doing live demos, it's going to happen. But I think it's definitely a nice reminder for all of us to go explore what other things are out there, get out of our own way a bit. I've shared all the links also in the chat. I've caught up with the folks on LinkedIn now. You should have all the links that everyone else does. Please go by the Effection repo. Taras, thank you for being here. Appreciate you. Go by the Effection repo and drop a star. Join their Discord if you're interested. And again, knowledge is power, friends. Read the paper, join the Discord, ask questions. And at the end, if you decide that you want to stay in that world that you live in and not fly, do it. Or if you want to sprinkle it across your projects and figure out if this is the thing for you, do it as well. But I appreciate you all being here, being patient with us, and being open to trying out new things. What a better space than open source for us to experiment here. So thank you for being here, and we will catch you in a next Open Source Friday. Next week, we're going to have the folks from Sopabase. And I have to say, for the folks that maybe were looking for that stream this morning, unfortunately, our guest Tyler had a bit of an illness, so we have to postpone that for next week. So next week, we're going to do a double day. We'll have a 10 a.m. Eastern, the team joining from Japan to show us Sopabase. And then I believe there is another stream coming on at 1. Not sure who it is. I will look it up and share it also on this chat so that you have it. But I appreciate you all. Thank you for being here. Thank you for supporting open source. And Carlos, we know nothing, but together we're learning and we're figuring it out. So catch you next week. I got to leave you again with that mega banger of a video. Y'all, I'm obsessed. Kudos to the GitHub video and social team, because it's a tune. It's a tune. Enjoy the GitHub Copilot Coding Agent launch video one more time. If you haven't given it a go, give it a go. If you have a Copilot Pro or Enterprise, you're ready to start assigning issues to your peer engineer. Is he smarter than you? No, but he's going to go do the boring stuff for you. So thank you for being here. Thank you for your support of open source. We'll see you next week.
I want it, I get it.